Hi everybody, and welcome to this lesson looking at Amazon's Simple Storage Service, or S3. Now, Amazon S3 has a simple web service interface that you can use to store and retrieve any amount of data at any time from anywhere on the web. Now, S3 is intentionally built with a minimal feature set that focuses on simplicity and robustness. Now let's look at some of the concepts that are within the S3. First and foremost, we have something called buckets, and a bucket is a container for objects stored in S3. Now, every object is contained in a bucket. So you can think of a bucket like a folder if you're familiar with Windows Explorer. Now, buckets have several purposes. They organize the S3 namespace at the highest level. They identify the account responsible for storage and data transfer charges. They play a role in access control, and they serve as a unit of aggregation for usage reporting. Now you can configure buckets so they are created in a specific region. You can also configure a bucket so that every time an object is added to it, Amazon S3 generates a unique version ID and assigns it to the object, which is referred to as versioning, which we'll take a look at a little bit later. Now, one thing to keep in mind about buckets is that they have a unique namespace. So they are basically addressable by the DNS namespace. So every bucket that you create in AWS has to have a unique name across AWS, not just across your organization. And when I take you through the demonstration, you guys will see how that's played out. Then we have objects, which are the fundamental entities stored in S3. Objects consist of object data and metadata. The metadata is basically a set of name-value pairs that describe the object. These include some default metadata such as the date last modified and standard HTTP metadata such as content type. Now, an object is uniquely identified within a bucket by a key name and a version ID. Third aspect is keys, which is a unique identifier for an object within a bucket. Now, every object in a bucket has exactly one key. Because the combination of bucket, key, and version ID uniquely identify each object, S3 can be thought of as a basic data map between bucket, key, and version, and the object itself. Now, every object in S3 can be uniquely addressed to the combination of the web service endpoint by bucket name, key, and optionally a version. Next, we have regions. Like I mentioned, you can choose a geographical region where the S3 will store the buckets you create. You might choose a region to optimize latency, minimize costs, or address regulatory requirements. Now, objects stored in a region never leave the region unless you explicitly transfer them to another region. Lastly, the consistency model. It's very important to keep this in mind, especially for the exam. Now, the S3 provides read after write consistency for puts of new objects in your S3 bucket in all regions, with one caveat. The caveat is that if you make a head or get request to the key name before creating the object, S3 provides eventual consistency for read after write. Now, S3 offers eventual consistency for all overwrites, puts, and deletes in all regions. Updates to a single key are atomic. For example, if you put to an existing key, a subsequent read might return the old data or the updated data, but it will never return corrupted or partial data. Now, S3 achieves high availability by replicating data across multiple servers within Amazon's data centers. So if a put request is successful, your data is safely restored. However, information about the changes must replicate across Amazon S3, which can take some time. So the table basically describes the characteristics of eventually consistent read and consistent read. So with eventually consistent, again, just like the name suggests, stale reads are possible. You have the lowest read latency and highest read throughput, whereas for a consistent read, it's the opposite, where you have no stale reads, but then the latency and throughput are a bit lower than eventually consistent. Now here you guys see an example of eventually consistent and consistent read requests when multiple clients are writing to the same items. So in the example on the left, both W1 and W2 complete before the start of R1 and R2. Now the W refers to write, where the R returns to read. Now for a consistent read, R1 and R2 both return color equals Ruby. For an eventually consistent read, R1 and R2 might return color equals red or color equals Ruby, or no results depending on the amount of time that has elapsed. Now the example on the right, W2 does not complete before the start of R1. Therefore, R1 might return color equals Ruby or color equals Garnet for either a consistent read or an eventually consistent read. Also, depending on the amount of time that has elapsed, an eventually consistent read might return no results at all. Now let's take a look at some of the important features that are within S3. Firstly, we have bucket policies, which provide centralized access control to buckets and objects based on a variety of conditions, including S3 operations, requesters, resources, and aspects of the requests, which are the IP addresses. The policy is expressed in the access policy language and enables centralized management of permissions. The permissions attached to a bucket apply to all of the objects in that bucket. Individuals as well as companies can use bucket policies. Now when companies register with S3, they basically create an account. Thereafter, the company becomes synonymous with the account. Accounts are financially responsible for the Amazon resources they create. They also have the power to grant bucket policy permissions and assign employees permissions based on a variety of conditions. You also have identity and access management. So for example, you can use IAM with S3 to control the type of access a user or group of users has to specific parts of an S3 bucket. Then we also have versioning, which we'll take a look at during the lab, but it's important to enable versioning if you want to do lifecycle policies. So basically, versioning lets you keep track of the history of the object. So you can see who has updated it, when it was updated, and if it was deleted. So when you delete an object from S3 with versioning enabled, it's never truly deleted from S3. And I'll demonstrate that during the lab. Additionally, they are the most common operations that you can execute through an API with S3, such as creating a bucket, writing an object, or storing by creating or overriding an object within a bucket, reading an object, deleting an object, and listing keys, which basically lists the keys contained in any of the buckets. Now when granting permissions, you have to decide who is getting them, which S3 resources are they getting them for, and any specific actions you want to allow on those resources. So by default, all S3 resources are private. Only a resource owner can access the resource. And the resource owner refers to the AWS account that creates the resource. So for example, the account that you use to create the buckets and objects owns those resources. If you create an IAM user in your account, your AWS account is the parent owner. If the user uploads an object, the parent account to which the user belongs owns the object. A bucket owner can grant cross-account permissions to another AWS account. The bucket owner does not have permissions on the objects that other accounts own. Now, it's very important that AWS recommends not using the root credentials of your AWS account to make requests. Make sure that you create an IAM user and grant them access to use such services. Now, the first diagram that you guys see on the top left basically shows an AWS account owning resources, the IAM users, buckets, and objects. Now, managing access refers to granting others permission to perform the resource operations by writing an access policy. For example, you can grant put object permission to a user in an AWS account so the user can upload objects to your bucket. In addition to granting permissions to individuals, users, and accounts, you can grant permissions to everyone, also referred to as anonymous access, or to all authenticated users or users with AWS credentials. So for example, if you configure your bucket as a website, you may want to make objects public by granting the get object permissions to everyone. Now, access policy describes who has access to what, and you can associate an access policy with a resource or a user. Accordingly, you can also categorize the available S3 policies by using resource-based policies, which is the image that you guys see on the right. Now, bucket policies and access control lists are resource-based because you attach them to your S3 resource. Now, for an ACL, each bucket and object has an ACL associated with it. An ACL is basically a list of grants identifying grantee and the permission granted. You use ACLs to grant basic read-write permissions to other AWS accounts. Now, ACLs use an S3 specific XML schema. Both bucket and object ACLs use the same XML schema. Now for your bucket, you can add a bucket policy to grant other AWS accounts or IAM users permissions for the bucket and objects in it. Any object permissions apply only to the objects that the bucket owner creates. Bucket policies supplement and in many cases replace ACL-based access policies. And unlike ACL policies, bucket policies are expressed using a JSON file. Then finally, we have user policies, which is the image you guys see on the bottom left. You can use IAM to manage access to your S3 resources. You can create users, groups, and roles in your account and attach access policies to them, granting them access to AWS resources, including S3. Now, S3 is basically a simple key value store designed to store as many objects as you want. Now, you store these objects in one or more buckets, and an object consists of the following information. It has key, the name that you assign to an object. You use specific object key to retrieve the object. Then you have the version ID. Within a bucket, a key and version ID uniquely identify an object. And the version ID is basically a string that S3 generates when you add an object to a bucket. Then you have object tagging, which you use to categorize storage. Each tag is a key value pair. Now, to manage your objects so that they are stored cost effectively throughout their lifecycle, we have to configure something called the lifecycle policy. A lifecycle configuration is basically a set of rules that define actions that S3 applies to a group of objects. Now, there are two types of actions that we can define in a lifecycle policy: transition actions and expiration actions. Now, in transition, we define when objects transition to another storage class. So for example, you might choose to transition objects from a standard storage class 30 days after you create them, or archive the objects to Glacier storage class 1 year after creating them, or 60 days after creating them, depending on your business case. The expiration actions define when objects expire, and S3 deletes expired objects on your behalf. Now, the cross-origin resource sharing, or CORS, defines a way for client web applications that are loaded in one domain to interact with resources in a different domain. Now, with CORS support, you can build rich client-side web applications with S3 and selectively allow cross-origin access to your S3 resources. And finally, S3 enables you to store, retrieve, and delete objects. You can retrieve an entire object or a portion of an object. If you have enabled versioning on your bucket, you can retrieve a specific version of the object also. Additionally, you can retrieve a sub-resource associated with your object and update it where applicable. You can make a copy of your existing object. Now, depending on the object's size, some upload and copy related considerations apply. For example, you can upload objects of up to 5 gig in size in a single operation. You can create a copy of your object up to 5 gig in size also in a single atomic operation. And additionally, you can use REST API to work with objects. or use any of the AWS SDK libraries.